This video will be concerning partially at the end firearms. We're going to be talking about melting points, hardness levels, and price points, which are more important than melting point, for various materials that are used for projectiles. But let's go into this really quickly. If you want to melt tin, lead, zinc, aluminum, brass, silver, copper, gold, platinum, you'll need a kiln, foundry, furnace, or forge. They're called those sorts of things. And you can make bird and buckshot or slugs. Slugs are molded. Buckshot is normally molded, but there is a way to make it faster and a lot more consistently. And then there's birdshot, made by this weird method where you melt metal after it's completely purified, or as much as you can, and let it drip through 1 or 2 millimeter diameter nozzles at the bottom of a sludge pan for it to melt from the bottom and pour off a little surface, bouncy, into liquid and form birdshot. The larger the diameter, the harder it is to do with that kind of medium, but there's a solution with that sort of. And you can, in fact, with help from people who want you to do it, reclaim all of the lead and steel and other metal shot that are fired at shooting ranges. And you can go out and pick up scrap at places where people shot ad hoc to make it to where it doesn't look like anybody's shot there. And you can also mine those areas if you want to by sifting and then sorting by diameter through running through sieves to find shot that's been fired, then go through the process of cleaning it up, and after that, sorting it by grade. And if you get enough of it that's good, just reuse it, or clean it some more, tumble it, round it off, or just melt the stuff down, pull off the crap off the top, and make reliable metal. And again, it can be made by pouring into a mold. It can be made by pouring it to if you're not aware of it, a wire mold, and then using a special device to crimp all of it into round balls. So you can have double-aught, triple-aught, or number 4 buckshot, or number 1 buckshot. Or if you want to make something for birdshot, you can easily do, again, simple method. It's this metal tray for melting it that's put on a hot plate with the temperature control turned off or disconnected or bypassed, and melt it into, through little holes like 1 or 2 millimeters across. You have to experiment with them. And it lands on a little metal sheet that can be steel or it can be aluminum, about an inch wide, right in front of it. Hundreds of little BBs going every second, landing in, dishwashing liquid or some other medium to make it cool and stay mostly round. They get pretty consistent, and then you sift that instead. Now, why am I bringing all this up? You can take birdshot rounds, mix them with wax or plastic, and make them into slugs. But can you make them into buckshot? Is that a good idea? Let's go on. Let's talk about the metals that you can melt versus metals you can't, versus what you would do with them. Dollar a pound day. We're going to talk about the $1 a pound or less materials that are used, that are available, that are in play for making birdshot and buckshot. Zinc. Zinc and iron are about 7 grams per cubic centimeter. Iron is also sold at about $1 a pound. So is lead, but it's much more dense, 11 grams per cubic centimeter. It's the reason it's used is it's also soft and kind of tough. Zinc tends to be hard and kind of shattery. Steel is ridiculously hard and ridiculously tough. As a reusable shot, it's easier to sift. It has almost no negative effects on the environment. And more importantly, you can easily mine it. But it's really, it's only good for birdshot, right? No, you can use steel ball bearings and that sort of thing for self-defense occurrences. And it's more likely to have a coating on it that makes it to where it doesn't rot. And again, did I mention it's easier to sift out of dirt? Then we get, if you're curious about other materials that have a similar density for iron and zinc, tin. But instead of $1 a pound, it's 16 a pound. Fuck. But anyway, using it sparingly, that's foreboding and spoiler alert, it melts at 450 degrees Fahrenheit. Lead melts at 600 something. Zinc melts at 787, but it's considered a low melting point material. Iron melts at 2800 degrees Fahrenheit, the type of iron that's used for steel shot. The melting point for copper is lower. It's at 1983 degrees Fahrenheit. Its density is 9 grams per cubic centimeter, and it's $5 a pound. Bismuth is also $5 a pound, almost the same weight, but it melts at 521 degrees Fahrenheit, but it gets brittle. But if you add the tin in, tiny amounts of it, it tends to make it a lot more malleable. At least, but it's not tough. It won't tolerate being hit. It won't stay in one piece. It'll shatter eventually. But it's a good compromise because even though it's brittle, it's also somewhat soft at the same time, which doesn't make sense. And it's used a lot for firing out of a gun. Now, bismuth, like any other element, can have reactions in the environment and cause problems. $5 a pound. Copper, same thing. Almost the same density. That's one of the reasons people are thinking of using copper shot. It's still heavier than zinc and steel and tin, but it can definitely work. Now we get on to the next layer. Nickel. Now it's only included here because it's usually sintered with tungsten, which I'm going to bring up, but it works out at 9 grams per cubic centimeter, like copper. The cost for it's $8 a pound instead of $5 a pound, like copper. That's why copper is being used for a lot of individual projectiles. It's still 5 times as expensive as lead, but suddenly it's a lot better for certain things. And it's just soft enough to go through a barrel without having the hardness level of iron or steel shot. And it's used as a coating on it sometimes. Now we get to, well, tungsten. $13 a pound. It's less expensive than tin. Yes, that's boss music. And it's hard and tough. And it's 19 grams per cubic centimeter. It's much heavier than lead, so you could easily mix it or cut it with something. So let's talk about the obvious things here. What can you use to glue it together with? That obviously answer is glue. You can get it as powder and mix it with something very, very sparingly to make it glue together. Polymers are used, glues, sometimes metals, tin, copper, manganese, silver. Yeah, you can make this stuff sort of solder shut. It'll solder together with other metals. You have to use nearly blowtorch temperatures. You can also use it with a silver soldering material as well. Next, tungsten, nickel, copper at unknown amount of price tag versus tungsten, nickel, iron versus tungsten carbide scrap metal can be just repurposed. The density isn't that great, but its penetration capability is amazing. Drill bit-based bullets. So, what if you could grind it into a powder? Liquid nitrogen shattering it? The stuff tends to be very tough, but tungsten by itself can be broken up. Tungsten powder at $25 a pound is more expensive than all of these things. However, you can cut it with something and drop the price to nearly the 16 a pound, 13 a pound range of tin, or just tungsten itself if you buy it in bulk. Bar, or, oh wait a minute, sometimes it's sold at 13 a pound for powder. Okay, what about other types? Well, $15 a pound, almost no melting point versions are available. This comes from recycling. Tungsten matrix or polymer shot from Kent or whatever, and relying on it being plastic with powdered tungsten in it, which you can, of course, recover the tungsten from. But that's $50 a pound, unless you dig it out of a berm, find out that it's shot, find out it isn't steel, assume it's lead, and try melting it and find out that it smokes, and you end up with this powdered stuff at the bottom. So what you do is you use a lower temperature, way below tin melting, and see if you get stuff that melts. Then bring it up higher and higher and higher, and eventually that first melt at the low temperature will get you the tungsten and a bunch of plastic. But you can get it out and use it to make tungsten plastic or tungsten polymer slugs or whatever. Or just separate it out some other way, I don't know how to do it, along with the steel you get out with a magnet, clean it all up, and you can just melt it into whatever you want to, including remelting it into any shape you want to. It's the plastic at this point that does it. Now, I want to point out that that $50 a pound rate for the tungsten that's being shot is by buying brand new shells from Kent. Getting it out of the ground would be no more expensive or time consuming than getting out lead, and it would be potentially better, but it would show up as something that would have a weird nasty smell to it and not want to melt properly. Sorting this stuff would be extremely beneficial and profitable to somebody who wants to do this because the plastic is easily cleaned for the tungsten. it can burn off. Now, reclaiming lead shot or steel shot is never 100% free of tiny rocks or sand or grit unless you run a magnet over it to get the steel separated and then clean it in something that relies on the steel being hard. And you basically tumble it like you're trying to make ball bearings. It'll tolerate it. You can literally mix it with the grit itself on purpose, and that will help polish the steel by running it through a tumbler. You can air and water wash it, depending on what you're doing with it, to get the stuff separated out even more, and then you can tumble polish it. Then you can melt it into new shot and or use that to separate out the other type and or use the temperature gradient method I just told you about to get the polymer-coated or polymer-sintered version of the tungsten out of it. Tungsten would be quite useful at that point. What's the rate for this stuff? Having it sifted out to where you get at least things that are the same size as pellets is $1 a pound. That's for assuming it's lead, but it could be steel, lead, and then everything else. Now, that's the same cost as buying brand new clean lead, but you get the advantage, think about it for a minute, of being able to get some steel shot and maybe some of this tungsten, which is, again, $50 a pound if you're buying it brand new. I don't know why anybody would spend that much money on cartridges. And again, yeah, it's more dense, it's better, blah, blah, blah. It's nearly as good as lead. Lead is much cheaper. And steel can be used instead. It does work. An ounce of material is still an ounce of material. If you're throwing 1 1/8 ounce down range at 1,500 feet per second or 1,200 feet per second, it's still the same amount of mass hitting. And you can always wax slug all of this stuff. Now, you can get $2 a pound air washed and or air water washed for $3, which also includes for the expense, they wash it and graphite coat it to where you get almost perfect shot. At that point, I wouldn't worry about any kind of grit material. Again, most gun barrels are made to take steel. And then finally, brand new lead shot. This is Amazon prices. It's $3 a pound because it's not the cost of the raw material. It's how much it costs when it's a finished product. And that's lead shot, and it's almost always whatever you're looking for. But you're spending $3 on it. Getting it for free, sorting it by size, means that you don't have to have this shot changed out. And then being able to wash it and dry it and graphite coat it for $3, it's the same cost. But just air washing it, whatever, somebody's able to sell this stuff and make a profit at $2, which means it cost them a lot less to do it if you could get something like this going. Now, pellet size. Again, 36 caliber, 70 grain is triple-aught buck size, approximately. That's 10 pellets downrange each shot from a 3-inch shell or 3.5-inch shell, depending on whether or not you put a wad stack in it. Next, 33 caliber, 54 grain, double-aught buck, 15 pellets downrange from a 3.5-inch shell. 3-inch shell with 2 ounces of load because someone decided 24 pellets, 30 caliber, 40 grain, number 1 buck needed a little bit extra oomph for the page I found it on. Now, the cost of these is not relevant. The point is, how much are you sending downrange with each shot? In the case of number 1 buck, which is, if you haven't figured out from the grain weight, it's equivalent to emptying an entire magazine, several maybe, of 22 caliber short, long, or magnum. And it can be brought up to magnum speed, just increase the amount of propellant. That's a lot. Most shooting incidents, self-defense or otherwise, involve 2 to 3 shots. Next, you can pack a ton of that stuff in an extra long version of a 410 shell and carry it as a pistol legally as long as it says it's 45 Colt on the barrel. And you can get a double barrel version of it. You can also get a 6-chamber version or 5-chamber version that's a pistol, but it's overpriced. Or you can build really cheap ones, double barreled, in your pockets. And if you really want 12 gauge, just make it a muzzle loader and just carry 2 double barrel muzzle loader pistols. Just a bunch of ideas and thoughts. I'm going to be looking up how to do all this melting down and cleaning. I've already done some of this for sifting the material and using a colander to separate out things, various size holes in it. And in my opinion, if you're in the middle of this pandemic, end of the world scenario, and you haven't considered any of this, you should. Number 1. Number 2, switching over to steel is the cheapest one of the bunch that involves the least amount of effort. It's really easy to run a magnet over a freaking pile of dirt. Just saying. Thanks for watching. Have a good day. Good luck with that.